Hello, in this video, we're going to be solving a first order linear differential equation using integrating factor method. First, recall the standard form dy ds plus p of x times y equal to q of x, and also the integrating factor if is equal to e raised to integral of p of x ds. Take note of these two. So we can now solve this equation using these tools that we have here. The first thing we have to do is to rewrite this equation in this form. So let's divide both sides by x. So that will be x divided by x times dy ds plus 2y divided by x equal to 4x squared divided by x. X cancels x. We have dy ds plus 2 over x times y equal to 4x squared divided by x, that is 4x. You will observe that this new equation now look exactly like the standard form by comparing p of x is 2 over x and q of x equals to 4x. So p of x equals to 2 over x. Let us now use this p of x to calculate our integrating factor. So that will be if equal to e raised to integral of, what is p of x? That is 2 over x. 2 over x ds. This equal to e. We can factor out these two. It is a constant. So we have 2 times integral of 1 over x ds. If is equal to e square. Whenever we integrate 1 over x with respect to x, that gives ln x. This equal to e. Suppose we move these two up, that is ln s squared, which is equals to s squared. That means if is equals to x squared. So our integrating factor is s squared. The next step is to multiply this equation by integrating factor. So that will be s squared times dy ds plus s squared times this s squared times 2 over x y equal to s squared times 4x, which is 4s cubed. This means that s squared dy ds plus s cancels x. We are left with 2 times x times y, which is 2xy equal to 4s cubed. This means that this whole left hand side could be written as dds of ys squared equal to 4s cubed. That is, by product rule, you will have this back. Let's continue. Integrating both sides with respect to x, we have ys squared equal to integral of 4s cubed ds. Ys squared is equal to integrating 4s cubed with respect to x, that gives x to the power of 4 plus k, constant of integration. Now, let's simply divide both sides by s squared. So that gives y equal to x to the power of 4 over s squared plus k divided by s squared. Y equal to x to the power of 4 divided by s squared, that gives s squared plus k. Suppose we want this s squared to be at the numerator, it becomes x to the power of minus 2. This is the required solution. That's it.